Today our topic is power method. Power method is implemented to find the dominant eigenvalue. This method only gives us the dominant eigenvalue. We use this method or implement this method with an initial guess. This method is an iterative method for finding the dominant eigenvalue. If we consider a matrix A, which is diagonalizable matrix without dominant eigenvalue. Suppose that the A matrix has n eigenvalues, and these eigenvalues are ordered in this way that lambda 1 is the greater eigenvalue in magnitude. So the power method will be applied to find out the value of lambda 1. Suppose y naught belongs to Rn is an initial guess, and k will vary from 1, 2 and so on. We define yk and zk to find the dominant eigen value. Zk will be calculated as a yk minus 1. If we want to find out z1, we will multiply the given matrix A with the initial guess y naught, and later this zk will help us to find yk. And yk will be gained in this way that the calculated vector zk will be divided by the maximum of zk, the entry which will be maximum in the vector zk. As k approaches to infinity, maximum of zk will approach to the lambda 1, that's the largest eigenvalue, and this yk will approach to cx1, in which x1 will be the corresponding eigenvector and c is real constant. Let's see an example. A is a matrix of order 3 cross 3, and we find the dominant eigenvalue by using the power method. We already know that these three values are the eigenvalues of this matrix, and lambda 1, the largest eigenvalue, is minus 11.3249 among these above three eigenvalues. Now we will implement the power method. Y naught is an initial guess. We select y naught as an initial guess. So z1 by the given formula is a vector which is gained by multiplying matrix A with the initial guess y naught, and maximum z1. The maximum z1 is minus 3, which is located here. And y1 will be calculated in this way. We obtain this y1 with the help of y0. This is our first step. Now we will use y1 and will obtain y2. For k is equal to 2, we will calculate z2, which is again the product of a. Now it is the product of a with y1, which is this vector. And maximum entry in z2 is written here, which is minus 13.333. Now we find y2, which is calculated by the given formula for k is equal to 2 as z2 over maximum of z2. This is a vector mentioned here. So with the help of y0, we have calculated y1 and later we calculated y2. And similarly, y3 can be calculated by using the same pattern, which is a vector given here. Repeating the same process, we obtain Z11. When we reach at Z11, we see that we obtain this vector and maximum Z11 is this value and Y11 is this vector. When we take common Z11 R2, we divide according to the procedure. We observe that this value is the approximation of lambda 1, which was mentioned before when we start this example. And this approximation is best approximation, and y11 is the corresponding vector, which is the approximation of the eigenvector corresponding to the lambda 1. We can also verify that a11 minus lambda 11 is this vector, which is close to the null vector. Thus we see that maximum of zk approaches to lambda 1 and yk approaches to cx1 as k gets large. Another example, A is a given matrix of order 4 cross 4. This matrix has 4 eigenvalues, which are given here. These two are the complex eigenvalues. Thus, the dominant eigenvalue is lambda 1, which is 20.453. Now we use POR method to gain lambda 1 and the corresponding eigenvector. Take an initial guess y0 and calculate z1, which is the product of A with y0, and maximum of z1 is 26. Now y1 is there. In the approximation by taking initial guess y0, we obtain y1. Now we will use y1 and we will obtain y2. And preceding the same procedure, z10 will be obtained in a vector form in this way, and maximum of Z10 is 20.453 and Y naught is here. Y10 is here. Now the maximum of Z10, which is 20.453, is the approximation of lambda 1. So PAR method is implemented to find the approximation of the dominant eigenvalue we have found of a 10th iteration, which is 20.453, and y10 is approximately along the direction of the dominant eigenvector x1, which is given here. The corresponding eigenvector is y10. We observe that the difference of these two vectors is very close to the null vector. And we have implemented PAR method to find the dominant eigenvector.